Now we'll start a new topic, theory of equation. And in this new topic, first we'll discuss algebraic equation, polynomial equation with real coefficient, and few problems from the exercise 5a and from classical Algebra-SK Mapa book. So প্রথমে আমরা ডেফিনেশন অফ অ্যালজেব্রিক ইকুয়েশন জানবো, তারপরে আমরা পলিনোমিয়াল ইকুয়েশন অফ রিয়েল কোফিশিয়েন্ট তার রুটস এই বিষয়গুলো নিয়ে আলোচনা করব। So now we'll move to the definition of algebraic equation. Algebraic equation. So what is the definition of algebraic equation? Let fx be a polynomial of degree greater than equals to n, whose coefficients are either real or complex. Numbers. Then fx equals to 0 is called an algebraic equation. Or you can say polynomial equation. It is also called polynomial equation. So আমরা algebraic equation ও বলতে পারি or polynomial equation ও বলতে পারি. So now the question is, what is the degree of the algebraic equation or polynomial equation? So the simple answer is the degree of the algebraic equation fx. This is equals to degree of the polynomial fx. So degree of fx equals to 0 is that algebraic equation is the degree of the polynomial. Now equation of degree 1. Now there are few examples. কিছু উদাহরণ আমরা দেখি. Example 1. Algebraic equation of degree 1. Algebraic equation of degree 1. This can be written as ax plus b. So I have written a0x plus a1. This is equals to 0. Where I said degree 1, that means the coefficient a0 is non-zero. And a0, a1 is either real or complex number. Next, this is called the linear equation. Now algebraic equation of degree 2, that can be written as a0x square plus a1x plus a2 equals to 0, where a0 is non-zero and a0, a1, a2 are either real constant or complex, and this equation of degree 2 This is called quadratic equation. Quadratic equation. Similarly, algebraic equation of degree 3. This is a0 x cube plus a1 x square plus a2x plus a3 equals to 0, where a0 is non-zero and a0, a1, a2, a3 all are either real or complex number, and this is called cubic equation. Now, algebraic equation of degree 4, a0 x to the power 4, a1 x cube, a2 x square plus a3 x plus a4 equals to 0, where a0 is non-zero and all ai are either real or complex for all I equals to 0, 1, 2, 3 and 4. And this equation is called biquadratic equation. So this equation is biquadratic equation. Now, if we think about the solution of the equation of degree 1, solution for equation of degree 1. So, for equation of degree 1, say here a0x plus a1 equals to 0 and a0 not equals to 0. So, in that case, the solution is basically x equals to minus a1 by a0. This is either real or complex. So we can solve it easily, equation of degree 1, but what should be the solution of any polynomial by any algebraic equation of degree 2 or polynomial equation of degree 3 and degree 4. So for solution, finding the roots of the equation of degree 2, we have Acharya formula. This is basically minus a1 plus minus a1 square minus 4a0 a2 by 2a0. So it is one of the famous formula, ax square plus bx plus c equals to 0. The solution of the quadratic equation, x equals to minus b plus minus b square minus 4ac by 2a. So that is the solution, and this formula is the Acharya formula. So now, similarly, is there any other method for solving? Is there any important general method for solving algebraic equation of degree 3? Yes, this method is called Cardan's method. Cardan's method that we will discuss later. আমরা পরে আলোচনা করব. And equation of degree 4, algebraic equation of polynomial equation. So for that case, we will solve it with the help of Theorem. So by using the Ferrari method, we can solve any equation of degree 4. Ferrari's method. For equation of degree 5 and degree 6, in that case, we need to think about more algebraic structure. Now we will discuss it later if we have some time. So now here is one important question. The question frequently asked in different B.Sc examination. State and prove or state the fundamental theorem of classical algebra. The fundamental theorem of classical algebra. Okay, and this question asked generally for 1 marks, and this is very important. So So what should be the statement of fundamental theorem of classical algebra? Statement তাহলে কি হবে? Statement, you need to memorize all the terminology here. Every algebraic equation has a root. Now question is, what should be the nature of the roots? It may be real or complex. So comma, it is real or complex. So root may be real or complex, but the statement is every algebraic equation has a root, the real or complex. This is named as the fundamental theorem of classical algebra. Okay, so you can prove it. This is your self exercise. Now there is another important theorem. What is the statement of the theorem? An algebraic equation of degree n has n roots and no more. n এর বেশি রুট থাকবে না, তার মানে that means an algebraic equation has exactly n root. So what is the meaning of the statement? The meaning is that is, if fx equals to a0 x to the power n, a1 x to the power n minus 1 dot a1 x plus a0, where a0 is non-zero and ai are either real or complex number for all I equals to 0, 1 to n, then by fundamental theorem, fundamental theorem states that it has a root. Then by fundamental theorem, with the help of fundamental theorem, we say that fx has exactly n roots, either real or complex. Exactly n roots, that means it has n roots and no more. Okay, now we can prove it with the help of fundamental theorem. So now there is another important theorem, that statements are also important. So fundamental theorem is done, statement is the theorem 1, theorem 2. We are writing all this information without. There is another important theorem, if alpha is a multiple root, that means the root occurs more than one times, multiple roots of the polynomial, equation or algebraic equation, fx equals to 0 of order r. So that means r is here greater than equals to 2, because it is given the multiple root. Then alpha is the root of the equation f dash equals to 0 of order r minus 1. That means if alpha is a double root, then alpha is a simple root of the equation f dash x equals to 0. If alpha is a root of multiplicity 3, then alpha is root of the equation f dash equals to 0 of multiplicity 3 minus 1, that means 2. Okay, so now we will do some important problem related to all the theorems and as well as the fundamental theorem of classical algebra. So here is one important problem. So question 1, this question is very, very important. The equation ax cube plus 3bx square plus 3cx plus d equals to 0 has two equal roots. Then prove that BC minus AD whole square, this is equals to 4 into B square minus AC into C square minus BD. And the equal root is half BC minus AD by AC minus B square. This is our problem. We have to prove first one important condition and then we have to prove what is the equal root. In this question there are two important parts. First we prove the condition, then we will find out what is the equal root. So now we will move to the solution of the problem. See here I just named this as fx equals to 0. So let fx equals to ax cube plus 3bx square plus 3cx plus d equals to 0. So this is our polynomial equation of degree 3 and it is said the equation has two equal roots. I am assuming that alpha is basically two equal roots. So and let alpha be a double root, the root of multiplicity 2, double root of fx equals to 0. Then since alpha is a double root, that means alpha is the root of multiplicity 2. So here alpha is a multiple root. So note, we can write here one note. If alpha is a double root of fx equals to 0 polynomial equation, then alpha is a simple root of multiplicity 2 minus 1. So 1 times. So simple root of f dash x equals to 0. So from this information by theorem 2, we can write f of alpha equals to 0 and f dash alpha equals to 0. So that implies f alpha, that means a alpha cube plus 3b alpha square plus 3c alpha plus d equals to 0 and f dash alpha. So what will be the f dash x? So this is 3ax square plus 6bx plus 3c. So 3a alpha square plus 6b alpha plus 3c equals to 0. Equation number 2. Now multiplying 2 by alpha. So now multiplying the equation 2 by alpha and subtracting from 1 and subtracting from 1. Okay, but we can write this equation 2 as a alpha square plus 2b alpha plus c equals to 0. That will represent equation 2. So multiplying 2 by alpha, equation 2 by alpha, and subtracting from 1. So what we will get? So here first equation is a alpha cube plus 3b alpha square plus 3c alpha plus d equals to 0 minus, just multiple this equation by alpha. So a alpha cube plus 2b alpha square plus c alpha. Okay. This is equals to 0. We'll subtract. So that means this is out. So b alpha square plus 2c alpha plus d equals to 0. This is equation number 3. So what is equation number 2? A alpha square plus 2b alpha plus c equals to 0. This is our equation number 2. Now we get another equation, equation number 3, b alpha square plus 2c alpha plus d equals to 0. So this is b alpha square plus 2c alpha plus d equals to 0. Equation number 3. Now from 1 and 2 and 3, we will use the cross multiplication. So from 2 and 3, we have, write alpha square, alpha and 1. What about the coefficient of alpha square? A. Coefficient of alpha is 2b and 1 coefficient is c. So we'll repeat it. A to b c, b to c d, again b to c d. We just remove first and last part. Start from here. So this is 2bd minus 2c square. So 2 into bd minus c square. Next we'll move to, here we are using the method of cross multiplication. So this is bc minus ad, and next to ac minus bd. So in that case, our alpha square is bd minus c square by ac minus bd, and alpha is bc. You just take this 2 and bc minus ad by 2 into ac minus bd. So now we can write alpha square, alpha whole square. So we just put here this value in the left side, bd minus c square by ac minus bd is equals to alpha, this value here, bc minus ad by 2 into ac minus bd. So what we will get the result? We will get bc minus ad whole square equals to 4 into b square minus ac multiple c square minus c square minus bc minus ad whole square c square minus bd. bc minus ad, ac minus ad is cancel, ac minus b square. So here we made the mistake, b into 2b, that means 2 is b square, not bd, b square. So 2 into square. So c square, b square minus ac, c square minus bd. This is bc minus AC minus BD. BC minus AD. BD minus C square. BC minus AD. BD minus C square by alpha square is, what is alpha square? Alpha square is BD minus C square by AC minus BD, and alpha is BC minus AD by 2 into AC minus V square. So this is correct. This is also correct. No, AC minus V square. So AC, what is alpha square? BD minus C square by AC minus V square, and alpha BC minus AD by 2 into AC minus V square, that whole square. From that we can write BC minus AD whole square equals to 4 into B square minus AC. We take minus here common, and C square minus BD. This is our answer. Now the question is, what is alpha? So here you just see also alpha equals to half BC minus AD by AC minus. So this is basically the value of the equal root alpha, and this is the condition. So we have proved here. Now we come to another important problem. The problem is related to the multiple root. How to find the multiple roots of a polynomial fx equals to 0. Okay. So this is another important problem here, how to find out the multiple root and what should be the procedure for finding the multiple root. So what we will do, we will write a question here first. The question is very, very important. Determine the multiple root of the equation. Multiple roots of the equation x to the power 5 plus 2x to the power 4 plus 2x cube plus 4x square plus x plus 2 equals to 0. Multiple root, that means the root appear more than one times. একবারের বেশি root একই element root হিসেবে আসবে. That is basically the multiple root. So what should be the procedure for finding the multiple root? Step 1, you will write fx simple. Step 2, then you will do evaluate f dash x. Step 3, you will calculate the HCF, first common factor, of fx and f dash x. Okay, so HCF of fx and f dash x. And what is step 4? You will do the HCF, that function is equals to 0, and you will find some x equals to alpha 1, alpha 2, and so on. So this will be the multiple root. So we'll follow this procedure. Solution, let fx equals to x to the power 5 plus 2x to the power 4 plus 2x cube plus 4x square plus x plus 2. Step 1. Then we need to calculate step 2, that means f dash x. What is our f dash x? 5 x to the power 4 plus 8x cube plus 6x square plus 8x plus 1. Now we will find out the HCF. Now we calculate the HCF of fx and f dash x. So this is the class 8 level problem, class 7 standard problem. So just you divide f dash x by f dash x and you will continue. So what should be the HCF? You will see here HCF of fx and f dash x. This is basically x square plus 1. Is x square plus 1. That you will check. Okay. In which way you have x to the power 5, 2x to the power 4 plus 2x cube plus 4x square plus x plus 2, and you will divide by 5x to the power 4 plus 8x cube plus 6x square plus 8x plus 1. Multiple it 5, so 5x to the power 5, 10x to the power 4, then what x. So in that we will continue. So now what is step 4? Now HCF equals to 0. HCF equals to 0. That implies x square plus 1 equals to 0. So x equals to I and iota and minus I. So I and minus I, imaginary number, I equals to where I is basically root under square root of minus 1. So these are the multiple roots. So therefore our answer is the multiple roots of the given polynomial equation are I and minus I. Okay. So thank you. Next class we will continue another important concept. But okay, we have one portion is remain. We need to continue. So this is a polynomial equation with the real coefficient. I said one more concept we required. So recall polynomial equation with a real coefficient. What exactly mean? The fx belongs to Rx. Okay. So the meaning of the point will let fx equals to a0 plus a1x plus dot dot anx to the power n, where an non-zero and all a0 an are a real number. Okay. Then fx equals to 0 is called, the coefficient are all real number, is called a polynomial equation of degree n with real coefficients. Okay. So as for example, say you have given fx equals to 2023 plus 2024x plus 2025 x square. This is equals to 0. This is a polynomial equation of degree 2, but with all the coefficients are real number, with real coefficients. Okay, or we can say here fx belongs to R third bracket x. If we take the example like this, fx equals to say 2x square plus 2ix plus 2023, where I equals to root under -1. This does not belongs to Rx because this coefficient, since 2i is, this coefficient is not a real number. So this is not a polynomial equation with real coefficients. Now here we will do many theorems, but we need to recall all the theorem and statement. What is the statement of the theorem? If an equation with an algebraic equation with real coefficient, this is very, very important, real coefficient has a complex root, alpha plus I beta, I is imaginary number, then it has also a conjugate complex root, also a conjugate complex root alpha minus I beta. The condition is beta non-zero, provided beta is non-zero. Otherwise, it has a real root, beta equals to 0. So, in other words, we can say statement as an algebraic equation with real coefficient, imaginary roots occur in an algebraic equation, imaginary roots occur in conjugate pair, Conjugate pairs, that means alpha plus I beta, this is the root. So z bar, what is the conjugate? Alpha minus I beta. So z and z bar, these are the conjugate pairs. That we know from the complex number concept. So now we'll do one important problem based on this theorem. You can solve this kind of equation, solve the algebraic equation x to the power 4 plus x cube plus minus 2x plus 6 equals to 0. Very, very important. What is given? It is given that 1 plus I is a root. Now solution. So what is our fx here? Our fx is x to the power 4 plus x cube minus 2x plus 6. So this is an algebraic equation of degree 4. So it has 4 roots. exactly 4 roots and no more with the help of fundamental theorem. One root is given, this is 1 plus iota. So if 1 plus I, this is a complex root and all the coefficient, here the coefficient is 1, the coefficient is 1, minus 2 and 6, all the coefficient are real. So we can say that then fx equals to 0 is a polynomial equation of degree 4 with real coefficient. Just you observe all coefficient are real, 1, 1, minus 2 and 6. Now we apply this theorem just since fx equals to 0 is an equation with a real coefficient and it has a complex root 1 plus I. 1 plus I is a root of the equation of 1, then 1 minus iota I is also a root of 1. So from one given root we get the another real, from one root, complex root, we have another complex root 1 minus iota, because we said if alpha plus I beta is a root, then alpha minus I beta is also a root, because the algebraic equation is basically with real coefficient and imaginary roots occur in conjugate pair. So 1 minus iota is a root, that means 1 plus iota is a root, that means 1 minus I is also a root. So we know if alpha is a root, then x minus alpha is a factor. So therefore we can say x minus 1 minus 1 plus I, this is a factor, and as well as x minus 1 minus I, this is also a factor. So this you can take, if x minus alpha is a factor and x minus beta factor, so x minus alpha and x minus beta is a factor of f. That we can say from the factor theorem. So by factor theorem. So now we can write here, what is this? This will be a simple calculation, x minus 1 minus I. You can write it here, multiple x minus 1 plus I. Okay, just you think it as this is your A, this is your B, this is your A, this is your B. A minus B into A plus B square minus B square. X square minus I square, x minus 1. So that will be x square minus 2x plus 1. This is plus 1 since I square equals to minus 1. So x square minus 2x plus 2. So that means x square minus 2x plus 2 is a factor of fx. Okay. So since it is a factor, therefore by the help of division algorithm, we can write fx equals to x square minus 2x plus 2 into qx. So because it is a factor of this, so remainder will be 0. Since remainder factor, that means remainder is basically 0. Here x square minus 2x plus 2 qx. Now what will be the qx? So therefore the qx will be fx by x square minus 2x plus 2. What is fx? X to the power 4 plus x square minus 2x plus 6 by x square minus 2x plus 6. Since it is a factor, so obviously we can write the numerator x square minus 2x plus 2 multiple of something by x square minus 2x plus 2. Okay. Now what is this? This will be x square plus 2x plus 3. So this point is cancelled out. So your quotient is x square plus 2x plus 3. Now what we will do? Now we will take quotient is equals to 0. That means x square plus 2x plus 3 equals to 0. From the by apply Acharya formula, so minus 1 plus minus root 2y. So what are the roots? So therefore, the roots of the equation x to the power 4 plus x square minus 2x plus 6 equals to 0 are 1 plus I is given. It occurs conjugates 1 minus I. We get another roots by doing the qx equals to quotient equals to 0. এটা করে আমরা অন্য দুটো রুট পেলাম. One is minus 1 plus root 2i, another one minus 1 minus root 2i. These are the 4 roots of the equation. Okay, now question number 2. This is very, very important. You prove that the roots of the equation, the roots of the equation 1 by x minus 1 plus 1 by x minus 2, 2 by x minus 2, 3 by x minus 3, this is equals to x, are all real. Okay, you have given an equation. You need to decide the roots are real or complex. So here we have to show the roots are real. So how to solve this problem? So what is given? The given equation is 1 by x minus 1, 2 by x minus 2, 3 by x minus 3 equals to x. It's a very nice equation, and you will see this equation is a polynomial equation. If you multiply this, and this equation is of degree 4. Okay. So what we have to show? We have to prove that all roots are real. Okay, but we assume that if possible let the equation has a root, the equation has complex roots. The equation 1 has a root alpha plus I beta. We assume it. If we decide this is a contradiction, that means all roots will be real. What is alpha beta? Where alpha comma beta are real number. Now, if we multiply this equation and produce the extension, what we will see? আমরা দেখব যে এর সমস্ত কোফিশিয়েন্ট হচ্ছে রিয়েল, since the coefficients of equation 1 are all real. So by the above theorem, if alpha coefficient are real, alpha minus I beta is alpha plus I beta is the root, then alpha minus I beta is also a root. So, and alpha plus I beta is a root. So alpha minus I beta is also a root of 1. Now, since alpha plus I beta is a root of the equation 1. So it satisfies this equation. So alpha plus I beta satisfies equation 1. We put in position of x alpha plus I beta. So 1 by alpha plus I beta minus 1 plus 2 by alpha plus I beta minus 2 plus 3 by alpha plus I beta minus 3. This is equals to alpha plus I beta. Again, since alpha minus I beta is a root of 1, so 1 by alpha minus I beta minus 1 plus 2 by alpha minus I beta minus 2 plus 3 by alpha minus I beta minus 3 equal to alpha minus I beta. This is equation number 2 and equation number 3. So now what we'll do, now we'll subtract 2 from 3. So now 3 minus 2, that implies 1 by alpha minus I beta minus 1 minus 1 by alpha plus I beta. So 2 minus alpha minus I beta. So 2 minus 1. So alpha plus I beta, alpha minus I beta minus 1 plus 2, 1 by alpha plus I beta minus 2 minus 1 by alpha minus I beta plus 3, 1 by alpha plus I beta minus 3 minus 1 by alpha minus I beta minus 3. This is equals to 2 I beta. So alpha alpha basically cancel. So now we just do the calculation and we will see minus 2 I beta by alpha minus 1 whole square beta square plus 2 into minus 2 I beta alpha minus 2 whole square plus beta square plus 3 into minus 2 I beta alpha minus 3 whole square plus beta square equals to 2 I beta. Now we take the common, it is common, minus 2 I beta 1 by alpha minus 1 whole square plus beta square 2 by alpha minus 1 whole square plus beta square 3 by alpha minus 1 whole square plus beta square. This is equals to 2 I beta. Okay. So now we'll think on the left hand side. If you take on the right hand side, so what will happen? So 2 I beta 1 plus 1 by alpha minus 1 whole square beta square plus 2 by alpha minus 1 whole square alpha minus 2 alpha minus 2 plus 3 by alpha minus 3 whole square plus beta square equals to 0. Now the case is this quantity is strictly greater than 0. So that means 2 I beta equals to 0. Since the expression within the bracket, the expression 1 plus 1 by alpha minus 1 whole square plus beta square 2 by alpha minus 2 whole square plus beta square 3 by alpha minus 3 whole square plus beta square. This is in fact strictly greater than 1. So this is basically non-zero quantity. This expression. So 2 I beta equals to 0. So that means beta equals to 0. So this proves that so here I just write not if possible, let's say suppose, but let us assume that. This, when we take alpha plus I beta equals to 0, Alpha plus I beta is a root. Here beta equals to 0. That means it is just alpha. It is a real number. So that means this proves that the equation cannot have a root. The equation cannot have a root alpha plus I beta where beta is non-zero. Or in other words, that is all roots of the equation 1